everybody, it's Mrs. Fossen. So we are going to be looking at the second page of our Capstone practice. We already went through A together. And so I'm just going to go through these in order, and I will just remind you of how we solved this one first, and then we'll just proceed. So in this question, we are solving for x. So just a reminder, you can use your graphing calculator or the Desmos app for all of these. And so one option is I could go to y1, enter this, and y2 and enter this, or if I was in Desmos, then I would type it in like this. Okay, so just to show you. Oops. And then when I'm ready to put the other one in there, why is it not staying in there? Hold on a second. Alright, I think I have to put this in parentheses. Yep, okay. So I have to put the whole exponent in parentheses for Desmos. And then for the other one, so you can see 3 to the x plus 2. For the other one, when I just want to graph a number, Desmos does require me to put an equals y in there. So now I'm just going to be zooming out, and I'm going to where y is 81. And then once you can see where those meet, you can actually just tap right there, and it's going to show you where they are. So I can see, since I'm solving for x, that x was going to be 2. Now, the other option, so we'd already done that, is you could find a common base between 3 and 81. So the other option is that common base would be 3. So it'd leave the left side alone, and then 3 to the 4th power, well, that's my 81. And then once those bases are the same, you could ignore the bases, and then the exponents become the problem. And then to solve for x, I would just subtract the 2, and I get the 2 there. The other option, and this is what we did in class, is then to make a log out of this. So I log 3 both sides, and then the original problem became the argument, and then those 3's can cancel out. So I'm just left with x plus 2. And then when I go to the math button on the calculator and scroll up and put the little 3 and 81 in, I'll get 4. And then to solve for x, I would just move the 2 over and get 2. So a lot of different options on how to solve this one. All right, the next one is we're going to find the solutions to the following problem, and it does say to check for extraneous solutions. So that is something we're going to have to keep in mind when we do the capstone. So since there's one log on the left side and one log on the right side, and they're both the same base, I can just ignore those logs, and then the arguments become the problem. And since there's more than one type of x, I will have to subtract the 12 over, so I can factor. And so now I'll make my x. So I need factors of negative 12 that get me this negative 4. And you can run your factor program, but those factors would become a 6 and a 2, with the 6 being negative. And so there we want to find the factors, or as we knew them as the neighbors, that when this meets this, you get this. So the first neighbor you worry about is what this term is and what this term is to make x squared. And so those are both just going to be x's. And then I showed you guys to make that face. So here's the top of the head and the bottom of the head. And I'm looking for these side numbers. So x times what can make this negative 6x, and that would be negative 6. And then x times what, following these loops, can make 2x, and that would be a positive 2. And then once you get your factors, you can set them equal to 0 and solve. So in this case, I'd subtract 2, so one answer is negative 2. And in this case, I'd add 6, so my other answer is 6. I will want to see, though, are any of these an extraneous solution? So I just need to see if I put these numbers back in, would it make the argument negative? So that's all I really need to see is if I put 6 back in. So if I take 6 and square it, that's 36. And then 4 times 6 is 24. So if I take 36 and subtract 24, my argument's 12. So that's okay. If I put negative 2 in there and square it, then I get 4. There's a subtraction sign. And then 4 times negative 2 is negative 8. And again, I get a 12. So here there's no extraneous solution. So both answers is what I would be looking for if this were a multiple choice option. So number 3 is another solving, and it's going to be similar to the fact that it's a log, but it's also going to be similar to like this. So what I need to do in order to solve this is I can't have the 2 logs over here. I need to have the 1 log. So the right side I can leave alone, and I'll be condensing this side down. And just remember there's an understood base of 10. And if I just kind of scribble these out, this plus is going to become multiplication. So it'll become 2 times this x minus 4. And so what I'll go ahead and do here is just distribute that 2 in. Okay, so I get 2x minus 8. That's all part of the argument, so I'm going to make sure you're aware of that by putting it in parentheses. And now to solve, I want to work backwards through this order of operations. And there is addition and subtraction, but it's part of the log, and there's multiplication, but it's part of the log. So I don't have to do these steps, I just have to undo the log, and that means I'm going to make an exponent, and first I'll need a base, which will be 10, just like the base of the log. And then I'll need an exponent, which is what this will become. And what this will become. And then what will happen here is your 10s will cancel out, so you're left with 2x minus 8. And then 10 to the second power, that's just 100. So from there, I'll add 8. And then I'll divide by 2. And when I'm done, I get 54 as my final answer. And just a reminder, most of the capstone is multiple choice, so just a quick heads up there. All right, the next thing we're going to talk about is number 4. So we're solving again. So it's not quite like number 1 where I could find a common base, but I could do, y1 and y2. So, but I won't. I'm going to show you mathematically. So working backwards through this order of operations list, there is addition, but it's part of the exponent, so I can't get there yet. There is no multiplication here because it's 5 to the x plus 4 power. I never said any multiplying or dividing. So now to undo the exponent, I'm going to make that log. So I'll log both sides. And then I'll need a base. So that's that little 5. And now I need the argument, and that's what this becomes. And then these 5s over here will cancel out, so you're just left with x plus 4. And then you can press the math button on your calculator. Just scroll up and put in your little 5 and 20. And we get this nice long decimal, which I'll write down some of it. And now to get x alone, I'm going to subtract 4. So I'm going to leave this decimal in there. And again, I'm not sure if this is multiple choice. I think it is. But I will want to round. And so 3 places behind the decimal, that 138 would become 139. All right, so that's number 4. Number 5. So on number 5, we're going to talk about the given transformations. So this is the base of the function, and this 3 means it's going to move down 3. This 1 means it's going to move left 1. So if you start to look in your multiple choice, like this says up 1, which it's definitely not. This is also up 1, which it's not. Instead, I'm looking for the down 3. So right now, this was the only one that's a down 3, so I know it's D. But I also see the left 1. And if you do remember, I told you as far as the reflection part goes, because that's the flip, that we will never, ever have a horizontal. It will only be a vertical. So our answer choice is going to be D. All right, this one we're going to rewrite it. Instead of an exponent, we're going to write it as a log. So we have not done this for a while. So here goes log. So the first thing I need for my log is the base, which is the base of the exponent. And I showed you this trick where you can make a capital L out of it. That. But once you start with the base, you jump to the other side of the equal sign. So I'll put the 7. And then I'll jump back, and I'll put the x plus 2. And so now from here, I have to identify what the A part is. So A is that little sub number 3. And B is the argument, so I'll put a 7. Okay, so the x plus 2 isn't any part of the answer, and you don't need to solve. All right, finishing up at the back. These two we're expanding and condensing, so when I'm done, I just want 1 log. So the first thing I'm going to do is move this back as a 2. And then, if you notice the x minus 3 squared, that will become x divided by 3 squared, which is just 9. So I'm going to go ahead and turn it into 9. So now I'm just looking for x over 9 as a fraction, and then bringing that log 4 back, which is what C would do. On 8, we're going to go from one log to several logs. So when I see 2 times x times the square root of y, well, first I want to remember that y is, the square root of y, sorry, is 1/2. And then these multiplication signs are going to become addition signs. And now I'll just put this ln back with each term. And when I get to the y, I won't leave the 1/2 there. I'll just put it, right in front. So that's going to make it be option number A. All right, let's take a look at 9. So when you do get to this word problem, the problem's already going to be set up for you. But it says you bought a piece of property in 2000 for $52,000, and it's increased in value over the years at a rate of 22%. So this is the equation. They're just working off of this one from our last chapter. And we have our original amount, that's the $52,000. We have 1 and our percent rate, so 22% as a decimal. And since it's increasing in value, they took this number and added it to 1, and that's where they got this. And then our t. So what we want to know is after how many years is this property worth 3 times the original value. So 52,000, and then you want it times 3 times the original value, is going to make it worth 156,000. So from here, whoops, no, I think I did not put enough zeros on. So I did 5,200. So nope, that's right. Okay. Here we are. So from here, again, you have this option. Desmos would be a good option here. You can do y1 and you can do y2. So if you want to see this in Desmos, first what I'll do is clear these out, and I'll put in the 156,000, and then I'll go to this one and I'll put in the other equation. Let's see. And remember, when you're just putting a number in, you will have to put an equals y after it. And then this is a y line, so it's a horizontal line at 156,000, which is really, I mean, that's quite something to get to on Desmos. So, I mean, if you probably can't see this, but I'm just zooming in and out. So there's that 156,000. What I can't see, though, anymore is the other line. So I'm just going to zoom in a little bit more and hope I can see that. But this is getting pretty tough to see on Desmos. So I don't think I would use this on Desmos. Let me switch back to the other screen and show you what I would do. What I would do is maybe move this 52,000 over first. And so when I move this over through division, I get this. And this is actually a lot easier to type into the calculator. So let's go back to Desmos. I'm going to refresh this so I get a clean window. And now I'm going to put 3 in, but since it's just a number, I'll have to put an equals y. And then I'll put in the 1.22 to the x power, which is our t, and then just look for where they meet. So I can see that's 5.25. 5.525 years. Now, if you didn't want to use the Desmos option, then once I get here, because I would still move this over, now to undo the exponent, I'm going to log both sides. So here goes the log on the left and the log on the right, and I need the base. And so I want the base of the exponent. I want this number, not this. So this goes here and here. And then I need the argument. So this will be the argument on the left side, and all of this will be the argument on the right side. And so what will happen on the right side now is these 1.22s will cancel out, and then I can press the math button, scroll up, put my numbers in, like that. And rounding, you're going to see we get 5.524, which is 5.525. All right, last thing we have to do, and I do apologize that these did not show up very well, but we are graphing this basic function, 2 to the x. So if you think about what that shape is going to look like, since that base is bigger than 1, It's going to be growth, so I'm looking for a lowercase r shape, which is happening here and here and here. So C is automatically out. And if you pick your numbers, sorry, we're picking them for y because it's a log problem. And we said in our cheat sheet that we'd be putting 0 in. So anything including 2 to the 0 power is 1, 2 to the first is 2, 2 to the second is 4, and then you can make your fractions. So what I'm going to do is just pick one graph to look at and see what happens. So in addition to that, my points will be moving left 3 and down 4. So if you think about the log, you have a vertical asymptote going like this, and so that wall is moving left 3, which happens on A. It happens on B, because I have the shape over here, but it doesn't happen on D. So let's just say, let's see what happens if I take this point 1, 0, and move it left 3 and down 4. So here's 1, 3, or 1, 0, and I'm going to move left 3, 1, 2, 3, and then I'm going to move down 4. So I was here, I went left 3, and down 4 says I should have a point way down here, but I don't. This one actually moved up 4, so A's out. So if you take a look at it now, here's 1, 0, it moves left 3, 1, 2, 3, down 4, 1, 2, 3, 4, and it ends up right there. And then I could also check 2, 1. Here's 2, 1, it goes left 3, and down 4, and ends there. So that is why our answer choice is going to be B. That's it.